So everybody, welcome to System Crafters Live. I'm David Wilson, and we're back with another Friday stream where we get together as a community and talk about whatever topic I've come up with for the week. And as usual, it's a last minute thing, but you know, we always find a way to make it work. So let me get this chat widget put in the right place, so it's not just like right on top of my head. I finally got it fixed this week, and the reason why it was not working is because I've been messing around with different streaming setups, and there we go. And I'm using like a different scene in OBS, and I forgot to put the chat widget there. So now we can actually see the chat on the screen, which is great, because I think that people were missing that in previous weeks. So let me say hello to the folks who are here so far. A lot of folks so far, which is great. Thanos, Nabaroon, RRA, GK Sudo, Matt, Nate, or Impertin, Colin McClear, Mark Rohrer, Robert Palchowski. Let's see, Rostislav's here. Andrew, Gio, Erwan, Arpana, Benoit. Thanks everybody for being here today. So, hello to Anton and Bill. Preparation is for dummies. Smart people can improvise. Well, you know, that's basically what I do every week, as I just come up with a topic and fly by the seat of my pants, and it seems to work fairly well, so I'm okay with it. Colin says, good topic this week. I was just trying to help instruct someone using the debugger. Yeah, so I haven't actually used the debugger functionality in Emacs very much so far. I mean, just a little bit, but today we're gonna sort of walk through it together and figure it out while we're doing it. It's called agility, yeah. Something like that. Hello to Jean-Baptiste and to Fade and Glenn C. Jones. Okay, so as far as updates are concerned, I want to mention again that people should join the Emacs Mastodon instance. Mastodon has been growing a lot in the past couple months, and the emacs.ch instance is a great place to join if you haven't joined any Mastodon instance so far. A lot of people there talking about Emacs. A lot of people you know from the community are there, and that instance federates with all the other instances in the sort of, well, not every, but you know, it federates with many of the other Mastodon instances. So if you have friends that are on other instances, you can still follow them, and you can also follow me if you create an account at emacs.ch, or you can create one at fossadon.org. You can follow me, David Will, at fossadon.org, and that is pretty easy to do. And you can also use the the mastodon.el client in Emacs to use Mastodon from Emacs. I don't really do that very often, but it is kind of nice to have that capability. And it's a fun place to be, actually. I've been having a lot of fun there. Also, when you're there, go reply to this post. I want to just get a little conversation started. So we're gonna write a post right now, and we can also see Mickey murdering people. Probably shouldn't say that. I'm gonna get demonetized here. I want to make a lot of new System Crafters videos next year. What would you like to see? So go to Mastodon, reply to this post. I'm gonna copy the link to the post. I'll just drop it in here in the show notes. And you know, just get an account set up. Come check it out, because it's a lot better there as far as, like, you know, community and actually people interacting with you and not being total bots. So definitely give it a shot if you are interested in some kind of social media there. Also, before I mention mastering Emacs, I want to say that I've actually been working a lot on my personal configuration on my dot files over the last couple weeks, trying to finally get around to cleaning it up, modularizing my Emacs configuration, and also plugging it in with Geeks Home. I haven't gotten into a place yet where I'm ready to show it, but pretty soon I'll probably do a new configuration walkthrough to show what I'm doing, because I've been thinking about this for a long time and I have a lot of different ideas, and I just haven't been able to explain it very well. So once it's actually working, we may do a stream where I just walk through the config, sort of explain how everything works, and then lead that into a series of videos about Geeks Home. That's one thing I definitely want to talk about a lot in the upcoming year, is just like, how do you get started with Geeks Home, and how do you actually make it work for the things you need to do? Because sort of out of the box, it doesn't seem to do a whole lot, but that's only because there's not a whole lot of home services built into Geeks yet. So you kind of have to write your own stuff. That's not a problem, actually. It's actually kind of fun to do that. So we'll go through all that stuff next year. I will make a lot of videos on that. So I'm sort of looking forward to having my configuration finished for whatever number of times it is I've rewritten it, but it'll be nice to have that done and also to show it on screen or on stream whenever we get that done. And lastly, I just want to say that there's a really cool way to support the System Crafters channel if you want to. Mickey Peterson, the author of Mastering Emacs, did a really cool thing where he set us up with an affiliate link for the book Mastering Emacs. And if you haven't heard of Mastering Emacs, it's a really high-quality resource about learning more about the sort of depths of Emacs. A lot of things we haven't been able to cover on this channel so far. And a lot of people here have actually picked up a copy, and I've also read it myself in the past. I think it's a really good resource. So if you want another way to learn about Emacs in book form and also want a way to support the channel, definitely follow this link, masteringemacs.org/systemcrafters, and a portion of the proceeds of your purchase of that book would actually go to supporting the channel. So that's it for the spiel. But thank you all of you who have done that so far. There's been quite a few of you who've actually followed through on that, and I really appreciate it. All right, so let me see if I missed anything here in the chat. Mark says, I'm very excited about the topic today. Analyzing Emacs errors, highly challenging for me. I do not understand the errors. There are no line numbers. I'm completely lost. I hope you will show solutions here today. Yeah, that's the point. I want to try to invoke some scenarios that are reminiscent of things that one would normally see whenever they're having problems with their Emacs configuration, and how you might be able to use Debugger to figure these issues out. Hello to Marcus Quincy. Thanks for joining for the first time. Hello to Kit Carson also. Also Vitaly, Purple G, Fikri. Who else am I seeing here? Richard Davis, Alejandro. I think I'm missing people from earlier. Okay. So, like we've been talking about before, today we're going to spend some time learning how to use the debugger or debuggers inside of Emacs. And this is specifically about debugging Emacs Lisp code, not like debugging C or JavaScript or something. So one thing we haven't really talked about so much on the channel so far is how to diagnose problems in your Emacs configuration beyond just looking at the messages buffer, hoping that you can figure out whatever cryptic error message got written out, and also like sort of hidden between all the other output messages that show up in the messages buffer. I'm sure that you've run into plenty of issues where you see something like, some EIEIO error or some weird XCB request error if you use EXWM. By the way, this is EXWM. I'm actually back in EXWM again. Anyway, so we're going to try to find better ways to debug errors in Emacs, especially if you are using a lot of third-party packages in your Emacs configuration, or if you've written your own Emacs packages. There's a few different ways that you can debug Emacs code or Emacs Lisp code directly in the program while you're using it, so you can try to diagnose some of these issues. And we're going to be following the Debugging Lisp Programs section of the Emacs Lisp manual as the resource for what we go through today. You can follow these links in the show notes to get to that online. If I were to pull this up, let's see if it does the right thing here. Okay, yeah, so it's like this typical Emacs manual site. You can go there and take a look at the documentation there. But since we know that Emacs has built-in documentation system, we can actually just use the info system to look at this documentation. So if you use the meta colon key binding to open the eval prompt in the echo area, if I were to do meta colon, I can just type in info elisp debugging, and then it will pull up that same page. So that's a much easier way to get those same documentation, Also, if I'm just sitting here in this org file, I can use Control-X, Control-E on that expression and also get there as well. So very, very useful to have that right at your fingertips whenever you're in the editor, so that you can figure out how to debug things when you need to. Hello to Case. Case is mega pumped about today's stream, yo. GK Sudo says, the extent of debugging in Emacs I've done is meta-x check parens. Well, you have to use that quite often. Hello to Gun. Arpana says, I'm fighting one error right now. Error in post-command hook, IVQ exhibit. Error opening directory, not a directory, myfile.txt. Yeah, well, you'll be able to figure out how that's happening, I think, after we get through the stream. Case says, I've never used check parens. So apparently Case writes perfect Lisp expressions that always have their parentheses balanced and never has a missing paren. Oh, okay, so he says he goes to the top of the file and use Control Meta F until it errors. That's one way to do it. Check parens is a little bit easier though. Wind Up Boy says Case uses paredit. Maybe, I don't know. Fellow worker John says, I just took delivery of my first rack mount server. Super noisy. Yeah, any kind of actual servers sound like an aircraft taking off. Gun says, can you also check which key map is currently active in a given context? You know, that's a good question. The answer is probably so. Let's see. Key map. Isn't there a variable for what the active key map is? Or maybe a function active? Key map. I just heard a noise from Mastodon. I'm not sure which one it's from. Anyway, if someone could pull up what the function is or variable is to get the current key map, we could definitely look at that in Edebug, I'm pretty sure. Or even the backtrace buffer. Kit says to balance the force, I make a lot of errors balancing parens. Yeah, well, that's what happens. Hello to Sukbatar. Sorry if I'm pronouncing your name incorrectly. All right, let's get to it. So, I don't have an example for what we're going to use for debugging, but let's see if we could think of a scenario where this might be useful. And maybe something that is a little bit more interesting than just like a plain Emacs Lisp function that I write and we just make it break. It would be nice if I could find a way to make a package that I use actually invoke an error. But it needs to be something that's not going to break the whole experience here. It's not going to kill the stream if I do that, but it will make my life more difficult. So let's see. Control H, K, tab. Org cycle. Is there a way that I can make org cycle break? I wonder. What functions does it call? What I could probably do is just override one of these functions and just make it do something wrong so that it just throws an error. That's probably a bad idea, but whatever. So org cycle set startup visibility. I kind of want something that's going to be nested inside of the code so that we have a better example. Maybe one of these. I wonder how much trouble I'm going to cause if I override this function. So let's pull up the scratch buffer. And I can take the definition of org cycle item indentation. That's pretty big on its own. Jeez. What a function. There's a lot of code there, so obviously it works. It must work. Hey says, we're here for the bad ideas. Well, you should please feel free to give me more bad ideas. Yeah, Gun says just divide by 0. That's probably a good way to do it. We could start with that. Maybe there's a hook also. So org cycle tab first hook. Yes, I said the thing. I know. I realized there was a bit of a meme forming after the last stream. I don't know why. What I said was not that interesting. Okay. Yeah, I definitely don't want to break org element at point. Or org element property. I mean, any of these are going to be a problem. I guess if I put advice in here and invoked an error, like an after advice, but then that requires that I remember what the syntax is for setting advice. Scratch, add advice. Advice add. Okay, so advice add. Let's just, I can't split that. Let's go to scratch buffer. So advice add, the symbol would be org cycle item indentation. We're gonna see if this actually does anything. Just start messing with your config until something breaks. Well, that won't be very hard. So the next thing is where. after? I don't know. What? Oh, this is the lambda that I want to put in here. So let's just do a lambda. We don't need any parameters because the original function doesn't have parameters. So in this case, I can just do a divide by 0. That'd be pretty funny if it crashed Emacs. And then optional props. Well, can I remove this advice? Okay. So probably should make a function for this. So defun. Wow, those SVGs are huge. Defun do bad thing. 1, 0. Okay, we're gonna use control meta x to eval that. And then instead of this lambda, we're gonna just pass the function in directly, do bad thing. The reason why I'm doing this is so that we can remove it also later, because I don't want this to be happening forever. Advice remove. Okay, so let's add the advice. Oh, unknown add function location. Okay, well, obviously I need to figure out what the actual location list is. Maybe view it in the manual. Core advising primitives, location. What's the back? Crap, let's see. Info, history back, okay. Location. Lambda's gonna be hard to remove, yes, that's right. I know. Advice add. Yes, I haven't induced the bug yet. I'm trying to get the stupid advice to put it in the right place. Where's the location stuff? Around. Oh, it must be using keywords. How about that? Cool. All right, so it's happy now. Let's go back into the org buffer and see if it does anything bad. Arithmetic error. Okay, so I think that's a good starting point. So we have an error that's happening as a result of me doing something in an org buffer. And now let's see if we can use some debugging functionality to solve that problem. Hey, Christian, nice to see you. Christian says, looking forward to not making mistakes in Emacs any longer. Well, I don't think I'm going to be able to cure that problem because I make mistakes all the time. Okay. So first of all, you know what? The great thing is I can't actually expand this text anymore to see what's inside of my notes. Wrong number of arguments. Let's do this. Okay, let's take that advice out. Boom. All right, cool. So let's talk about how you get into the debugger. So I guess I didn't mention before, there are actually 2 debuggers for Emacs Lisp in Emacs. One of them is just the basic built-in debugger, which I think is called just debug. And then there's also one called Edebug, which is a little bit more powerful and a little bit more familiar if you've used source level debuggers in other languages before. We're going to start by looking at the normal sort of standard built-in debugger because a lot of what it provides is what you need on a day-to-day basis. You often don't need the Edebug debugger unless you are writing an Emacs package and you want to be really specific, stepping through code and stuff. So a lot of value can be had by just learning about this stuff in the regular debug package. Oh, the restream chat logs are lagging. Yeah, that's just the way it is, unfortunately. I would like to use a different service for this restreaming thing. It's starting to annoy me, but I haven't had time to look that up yet. Okay, so what we saw is that when I add this advice to do the bad thing, and I press tab, now we see this arithmetic error. Obviously, we can go into the messages buffer and see there's an arithmetic error in this do bad thing function, but that's not good enough because it doesn't tell you where the error happened. It doesn't tell you why. A lot of times whenever these things happen in practice, it's whenever you've maybe updated all of your Emacs packages or you've set up a new package and there's like some weird conflict between 2 things, or maybe there's some old piece of config that you have that sets up a hook that does the wrong thing. I actually had a similar problem like this today, in fact, because I updated my MU4E configuration and I had something in my config, or actually I updated the MU4E package, and in my config, I was referring to an old version of a function that they renamed and they didn't set up an alias or something. So then when I was trying to delete mails in my MU4E buffer, it just started giving me errors, and I had to go figure out why that was happening. So useful for that. So the first thing you can do for investigating something like this is this toggle debug on error command. So if you were to use metax and type in toggle debug on error, what this does is turn on debugging mode, and anytime any function throws an error, the debugger will stop so that you can inspect what's going on. So if I go up here and press tab now, it's going to put us in this backtrace buffer, and it says debugger entered Lisp error, arithmetic error, and then you get the entire stack trace that explains sort of where you ended up to get here. So it started from, I'll tell you, if you've never looked at a stack trace before, basically what this is the set of, or the list of all the functions in order that got called, or I guess in reverse order, to get to where the code currently is. So the very last line is actually the first function call in the stack trace, where we're calling command execute, because this is coming from a key binding. Now, obviously, this is not the entire stack trace. There's probably things happening before this, but for whatever reason, this is the amount of the stack trace that Emacs gives us for this this error. But it's good enough because we can actually see sort of what the context is. So command execute calls funcall interactively to call org cycle. Then we get into the execution of org cycle. Then the org cycle item indentation function that I was adding the advice to. Then we see apply do bad thing. This is the advice system actually saying, okay, there's a function that needs to be called after org cycle item indentation. So let's call that by using apply. And then inside of do bad thing, we can see that we have this division function with the parameters 1 and 0, and that's where the error occurred. So that's cool. That gives us the ability to see where the problem is happening. But what can we do at that point? Like, what can we actually do to inspect what's happening here? I think I'm going to have to take off my advice so I can expand this next section really quickly. Let's go and let's just expand both of these so that we have access to everything. I'll put the bad thing back now and then press tab again. Okay, so now we've got our backtrace up. Let's just move this a little bit. And I want to try out some of these commands. So in the backtrace buffer, you can use a number of bindings for inspecting what's going on in the code. So I haven't tried this yet, but my understanding is that if you put your cursor on a particular line, then you can use something like V to display local variables of the stack frame. So if I press V, now it expands that description under that function to say what variables are currently set in that function call. So these may be things that are like local to the invocation of this function, because obviously there's like a whole universe of variables that are active in Emacs at this moment, but these must be the ones that are actually sort of relevant to the execution. If we were to go down to this org cycle item indentation maybe and press V, okay, no locals there, no locals there. So maybe it's just the local variables of the function that got executed. Let's see what else we have. No locals in any of those except for command execute. So I wonder how we can make this a little bit more interesting. So what if I go and use a let here? So x is 5, and then we divide x by, whoops, we'll also say y is 0. Divide x by y, we'll reevaluate this, and then go and try to expand that again. Okay, so now we can at least see that we actually are in the let expression, and I guess it gives us the ability to see the locals there anyway, but if I press V here, it doesn't give us the locals. If I press V here, it does tell us x is 5 and y is 0, so it does give you some of the context about what's going on in the function at the time that you call it. I was hoping you would see more variables, though. It would be kind of nice. All right, so the next thing is the P and N keys for moving to the previous and next stack frame. So some of the things I was doing before were just using the arrow keys, but I can use like N to move to the next stack frame and P to move to the previous. And I can just do the same thing with pressing V on any of these to expand them. So you don't have to have only one of them expanded. You can expand any of them at the point where you have your cursor. And then they have another one saying add, plus sign for adding line breaks to the stack trace to make it readable. So I think it means for things like this let here, where there's like a really compact expression that is like a really long single line. If you put your cursor on that line and press the plus sign, then it pretty prints it effectively. I don't know what I just did. All right. Oh, okay. So somehow I managed to exit the debugger. Let's just bring it back. So I'll go down here again, use plus sign. Whoops. Yeah, there we go. And then you can see it basically pretty printed, so it's easier to read. Sometimes you'll end up with a stack trace that has very, very long lines of code. I wish I could make one of those happen, because it does happen in certain cases where there's just really gnarly stack traces. But at least it shows you that you can make that look nicer when you need to. And if you go back to the line and press minus sign, then it puts it back on a single line again. It can be pretty handy. Gun says, how did the locals seep into your code? I don't know. Are you talking about the ones right here? I'm guessing it must be because of the debugger. Maybe it just inserted some stuff in there, but I'm not exactly sure about that. Okay, so back to... Oh, and also if you press Q, Q is kind of useful because it closes the backtrace buffer, but also it sort of releases the sort of nested execution prompt for what the debugger is doing at the moment. Because as you notice, it's breaking at the place, or the code is halting at the place where the error occurred so that you can inspect it, but Emacs itself is still running. So how is that possible? There's something, let's see. I don't know if I can do that. Info search, recursive. This is going to be terrible. Yeah, that's not going to work. Okay, so let me just pull up Q browser. So Emacs recursive. It's not prompt, is it? Yeah, recursive edit. It's basically a way to have, like, you know, multiple lines of execution happening at the same time, and that's what allows you to like have an error in Emacs, but it not totally crash Emacs. So, good thing to sort of know about, but I didn't find the right place in the documentation. Let me close this. Go away. Yes, leave page. Thank you. All right. We don't really see any ... forms in here, but sometimes there will be some abbreviation of the stack traces. Like some of these things might be ... instead of like having the actual whole code visible. And apparently this period key binding will expand all of those in case you need to see like the whole context of the code that's executing. I mean, it basically writes out all the code that's involved with what's being executed at the moment. Though it doesn't seem to do that with cycle item indentation here. It gives you a link to, if you click on it, you can go to the actual definition of the function, which is useful. Definitely that's useful, but some other times you see like actual nested code. Maybe that only happens whenever you have like a let inside of the function definition where the error occurred. So let's say inside of org cycle item indentation, if we were to put an error inside of like org list parents a list, I wonder if any of these are easier to override directly with an error, so we can see a bit more into the process. Let's pull that out. Org parents list a list. Man, so many functions that are so long. Org list get nth. Yeah. What about well, let's try it again. Let's see what else we got in here. Org list get item end. That could be good. Hey, okay. Maybe we can just throw something else in there. So if I go back to my scratch buffer. Oh, no, that's not what I wanted. Scratch buffer, thank you. So let's remove this advice, and then we're gonna override this function instead. So org list get nth. Here we're just gonna do this whole, you know, rigmarole of something divided by 0. And I'll have to have another version of this function so I can just reevaluate it to get the old behavior back and not drive myself crazy. Okay, so now if I were to go back into the org buffer, hit tab again. Oh, interesting. Apparently whatever code path I'm on didn't hit that problem. that I just inserted. Org list item get end. Org list item. All right, not the best example. So let's just fix that one so we don't screw it up. Hey, Osloy. All right, let's see what I have in my notes. So another thing that could be useful, a couple things actually. Flag the current frame so that the debugger stops again when it exits. That's, oh, whoa. This is not what we can see right now. Yes, we're here only at inspecting backtraces. So there's a couple other things like toggle print circle for the frame. I don't really know what that means. So let's take a look at it. Let's go back and put our little hack in. I'll go and add our little thing, and then I'll try to run this. Cool. And then I'll go down to this stack frame and press the hash key. Print circle is now T for this frame. I don't know what that does. I don't see anything happening. Okay, Fade says it's for printing circular lists. So if you have a list or a sort of a list graph, a tree that has circular references, or maybe it's an infinite list, then apparently you can deal with that more effectively. That's good. I don't know how you would know that it's going to be a problem until it hangs Emacs, though. Also, there is the colon key for toggling print gensim, and probably we don't see anything here because we're not using any code that's been generated by macros. So gensim is something that you see whenever someone writes a macro. They're trying to like generate a unique symbol, but yeah, we don't have a good example of seeing that right here. So we've seen all of these keys just to sort of inspect the stack frame, but there's also stuff you can do for like continuing execution. So if I were to be in the buffer here and press C, it's going to try to continue the execution, but we're still at an error. So you still see the arithmetic error at the bottom. Sometimes you'll, we'll have an example of where we stop the debugger in a place where there's not actually an error. That might be actually a bit more useful. Gun says, what is frame? The stack frame? Yes, the individual line for that represents a stack frame in the backtrace buffer. Okay. Maybe it's better to show these commands using a different debugging method. So that was us looking at toggle debug on error. So that's on right now. If I were to run toggle debug on error again and then hit tab here, then it would be back off and we just see the error written to the messages buffer or to the echo area. So it's just something really easily you can turn on just to get a stack trace if something weird is happening, and then you can figure out what part of the code it's coming from. Maybe it's in one of the hook functions that you've defined, or maybe you could sort of tell which function from which package you're using is causing the issue. So that by itself can be pretty useful. There's another really nasty case of issue where if you run some code that causes an infinite loop and it causes Emacs to hang, then you don't know what actually caused that infinite loop to happen. But usually in Emacs, you can press Control G to break out of the infinite loop so that you can get control of Emacs again. So there's this toggle debug on quit, and quit is basically anytime you press Control G. Control G is quit. If I were to use Control HK and then look at Control G, it calls the keyboard quit function. So it's just calling quit effectively on the current execution. So if we were to run toggle debug on quit, if I press Control G, it won't do anything because we're not actually executing any code at the moment. But what we could do is go into our scratch buffer and change this function to effectively do an infinite loop. Perhaps it calls itself recursively. Maybe we don't want to do that. Maybe let's just do an infinite list somehow. How would I do that in Emacs? Because I don't really use looping structures very often. One way would be creating an infinite list and using mapcar over it. Let's see, infinitely, repeat. Okay. Return a new list of linked in with each element being X. We don't have an easy function for that. So is there like there's a do, is there like a do macro? Okay, bind variables and run body forms until end test returns non-nil. Okay. Oh, macro is obsolete, use CL do instead. Cool. Take a look at that. So then what if we do CL do? We don't need to initialize any variables here, and the end test is just going to be nil. That will make it run forever. And then we can say message, oops. Okay. There we go. So let's try to just run this directly and see what happens. Okay, so Emacs seems to be hanged. You can see this little spinning cursor here. If I press Control G, because I have that toggle debug on quit turned on, you can now see that we are able to enter the debugger to see exactly where the infinite loop was happening, because it just pops right into the place where I guess the current thread is running. I don't really know exactly what you would call it. It's not really a thread. It may be a continuation of some sort. But you see the stack frames where we were in a while loop that prints the message oops. So it's definitely in the code that we wrote. And then it all goes back to command execute. And we're coming from eval last s expression, which is true because it's what I just did. I used Control X, Control E to run that code. But let's go and use our good example again. I'm gonna use Control Alt X to reevaluate this do bad thing function. And then I'll go back into the org file and press tab here. And now the oops loop is going. I can't do anything. I can't click on anything. I mean, it shows that it responds to hover, but I can't click it. But then if I press Control G, then, whoa, that didn't work that time. Let's try it again. Oh, I think it showed up at the end. Control G. All right, here it is. So we get that stack trace. If I were to go and turn off toggle debug on quit just by running that command and press tab again, then it just runs until you press Control G and it does nothing. So I'll turn toggle debug on quit back on, make the code run again. You see oops in the echo area, press Control G, and sometimes the backtrace doesn't show up for some reason. Not sure. Whoa. Wow. Okay. Interesting. Not sure why it doesn't show up some of the time. Interesting. I'll try it one more time. Yeah. It failed to work this time. Thibaut says, when you talk about Emacs debugger, is this a debugger for Emacs Lisp or something bigger? It is a debugger or debuggers for Emacs Lisp. All right. So that's pretty useful in itself. Like if you ever end up with a situation where something is hanging in Emacs, especially if you're using something like EXWM, it can be really useful to use toggle debug on quit so that when you use Control G to quit the current command execution, you can see where in the stack frame that, or where in the code the error could be coming from. Now, obviously, this isn't working perfectly. It worked right here when I did mini buffer quit. Like I pulled the mini buffer up, Control G, and it gives me a stack trace for that. So actually, here's a pretty good example. So check this out. We have some really ugly stuff here. Wow. I pressed J and it went away. All right, I can make that happen again. Here we go. So I'll go down to one of these lines and I'll press plus sign. Then you can see how it pretty prints it and makes it a lot easier to look at. That's kind of nice. What else? Maybe if I press V on some of these lines, we'll see some interesting locals. Yeah, none of these are showing me anything. Okay. So completing read defaults. I wonder if this is what was wrapped around it, like closure, basically. So you see like a mini buffer default, inhibit read only, mini buffer completing file name. So some of that stuff is pretty useful. What if we try in Scratch? Let's put this back to what we had it do before. Divide X by Y. And here I'm going to set, what could I set? Lexical binding to, well, what is it right now? Is it true? Let's set it to nil. I want to see if that variable override shows up there as well. So I'll reeval this, go back into the buffer, press tab, toggle debug on error, press tab again. Okay, so if I go down, go down and press V here, it does show me lexical binding. So it is possible that you can get some information about like defined variables, like actual global variables that have been overridden, that could be pretty useful. All right. So the next thing that's kind of useful is this debug on message variable. There isn't an easy toggle debug. I don't know why this thing is flashing like crazy. So there's nothing for setting the message through a toggle command. Let's turn that off too. But this could be pretty useful. Instead of causing an error, like maybe you see a message being written from a particular package and you have no idea which package is writing it. Maybe it's writing an error message instead of throwing an error. So the Emacs error system doesn't consider it an error, but it says something that you need to deal with and you don't know how to get to it. It can be pretty common, actually. We go into the scratch buffer. Let's take out this division by 0 and instead say message oops, and then reevaluate this function. All it's going to do is say oops. Okay? And if I go back into this buffer, press tab, well, didn't do it that time. Maybe I need to go fix my... I don't know why my scratch is showing up in the wrong place half the time. Gun says, does it trigger any Control-G key presses? Let's see. Oh, did I need to add this back? Okay, let's go into this buffer, press tab. Oh, it's probably actually writing it out. I'm just not seeing it. So messages. Yeah, so it's writing out oops. We just didn't see it. So what we'll do is use setQ debug on message oops and see if the debugger will stop on that. Let's go back to scratch buffer. And we'll drop this in right here. So I think it's like a regular expression here. So if we go into the buffer again, press tab on this line, then it will say debugger entered, Lisp error, oops. So it actually caught that message call that prints out the string oops. We're not matching it exactly. We don't have the exclamation point at the end. So it shows you that you can get like a substring. You don't have to be very specific about what string you're matching. So we got the whole stack trace here, which is nice. And we can also continue the execution. So I was showing you these keys here for debugger commands. C will allow me to continue the execution where we left off. So if I'm here, I can just press C and it will just go on as it went before. So if you want to just use this to inspect some behavior, like a package is writing some message out, you can set that debug on message. Just make sure that when you're done, you set it back to nil so that it doesn't keep popping up in places where you don't want it to. So let's see if we can actually make this work as a regular expression. So I'm going to use exclamation point. Let's see if that does the right thing. I'll press tab here and it does catch it. I can also do caret O and eval that string and then go press tab. And then once again, it will catch oops. So you can use full regular expressions so that like if maybe it's writing out different numbers every time, you can actually have a pattern that you match, anything you want. So that it can be really useful for that. I'll go back and set this to nil so that we don't hit that again. And then I can press tab and then it just writes out the message without being stopped. So really useful thing to use for certain packages that just write things out to the echo area or the message buffer, and you want to sort of see where that line is coming from, because you know if you use 30 different packages in your configuration, sometimes you'll see stuff in the message buffer you have no idea where it comes from. Okay, debug on entry and cancel debug on entry. Pretty useful because it allows you to mark a particular function so that you will enter the debugger whenever you enter that function. So if we wanted to, we could set debug on entry on this org cycle item indentation call. If I just go to the meta X and say debug on entry, I think it by default picks up the name of the function that the cursor is on. So I can just press enter again to select org cycle item indentation, or I can just type the name of any other function because it gives you a list of everything. So if you use a selector system like Vertigo, it's very easy to sort of filter down to the function you're looking for. I'm gonna press enter right now though, and then go back here and press tab on this item. And it shows us here that we are stopped at a frame. I think the star here is telling us that we're sort of stopped at this frame of org cycle item indentation. So it gives us the ability to do anything we want to do at this point. We can continue execution with C. We can exit out. We don't have to do anything else. Also, let's try out some of these other, some of these other commands here. So there's this B command that you can use in the backtrace buffer, which is not so... It may not, the way it's described may not sound very obvious, but I think I understand what it's supposed to do. What it says is that it flags the current frame so that the debugger stops again when the frame exits. So I think the point is that you can get it to stop again whenever the function is about to return to the function that called it. So we can try this by pressing B right here on this line. Does it mark it or anything? Yeah, it doesn't actually tell me. Yeah, I don't see anything. No feedback whatsoever. What just happened? Okay, I pressed B on the top line there. Oh, okay. So we're in a nested execution here. This line is not a function call. Sure, fine. Let's go back to where we were. I'll press B. Then I'll press C to continue. Okay, cool. So debugger entered returning value nil. So apparently this function returned nil. That will give us some insight into what the function that we stopped in is going to return back to the function that it came from. So could be pretty useful for debugging certain kinds of problems where some code is calling another function and you want to see what value comes back from that without having to go and like insert the call to the message function to write that value out inside of the code. Ozloy says B sounds like finish in GDB. It might be. I mean, I'm sure a lot of this stuff is very inspired by GDB. Also, you can use U to undo that flag. So on that frame, you could just, well, let's see. Maybe if I press tab again, then press C. Okay, so it still does the returning value thing. Maybe if I press U here, it will clear that. Press tab again, press C. Okay, let's do it one more time. Right here, I'll press U. Oh, okay, so that's how you can see it's marked. It has the star. Interesting. Okay, so I press C here. It says returning value. Press Q, press tab again. Okay, I'm not sure exactly what U is supposed to do in that context then. It says undo the flag on the current frame. Well, it's not doing what I expect it to. Okay, let's say press U, then press U again, maybe? Then press C? Yeah, it's still catching the return. Whatever, that's fine. It doesn't really bother me, but we might want to use cancel debug on entry to remove that debug on entry. Maybe that will solve the problem. So if I use cancel debug on entry, now the nice thing about this interactive command is that it will only show you the list of functions that are actually marked for debug on entry. So we only see org cycle item indentation here. I can press enter to remove that debug on entry on that command. So if I go back here and press tab again, then the thing doesn't show up anymore, which is great. There's also another one that's really, really useful. Debug on variable change. If for some reason, some package is changing a variable in your configuration or just in the global context of Emacs, you might want to know where it's happening so that you can stop it because it might be driving you crazy. So you can use debug on variable change to do this. So let's see. What variable could we change in the scratch buffer? I mean, we could set lexical binding to nil. I don't know if a let binding is going to do it, though. So this is a buffer local value. Okay. Let's try that, actually. We can set lexical binding to nil. I'm going to use debug on variable change. It's going to automatically pick up lexical binding here. And then once it finishes executing, taking some time. Wow. So somehow it got all the way into some EXWM. Oh. Okay, this is probably a bad example of a variable to use. Oh. All right, so we may have just killed Emacs completely. Cancel debug on variable change. Let's try that. Okay, maybe we're okay. So let's define our own variable then. Def var my variable. We'll set it to 5. Eval that. Then here we're going to set my var or my variable to nil. And I will eval this function. And then I'll go here and add the debug on variable change for my variable. And then let's go hit tab. Okay, so it even works with sort of local overrides of a variable, which is great. So we see here that the let binding set my variable to nil. Debug, implement debug watch. It must have injected some code to make this work. But we can see that it's inside of that let block that I had set that variable in. So super, super useful. I think that you might find a lot of weird issues in Emacs by using this, this one alone, because it can tell you why in a particular buffer, maybe a buffer local value got changed to something that you didn't expect in a certain thing, like maybe org mode buffers or some other kind of buffer, and you can figure out which package set that, or maybe even one of your own one of your own configuration hook functions or something did it. Gun says, for Emacs from hell, watch point. I wonder how that would work. All right. What other commands can we take a look at? Let me remove that let binding thing. Oh, that was kind of interesting. Actually, let's take a look at that again. I'm going to press tab. All right, so the let binding set my variable to nil. Okay, that we saw that happen, but I press Q, and it says ending let binding of my variable. So you can see even whenever the scope of that let block ends and the variable basically gets reset to its previous values. That may give some clues as to how Emacs is implementing the shadowing of global variables using let bindings. So kind of interesting. What else? We can do things like returning a value for the currently executing frame. So maybe this function do bad thing. Here, let's check this out. Let's try this. The result is %s. We're going to say divided x by y again. Let's take this my var out. Whoops, I keep pressing Control S reflexively, but that's not the right thing to do here. I'll eval this function, and then I'll go press tab here. And it gives us the arithmetic error. So what I could possibly do is press R to return a different value for the currently executing frame. So I'll press R. It will ask me for the value. I can say, 15. Cannot return a value from an error. Okay, fine. So it must just be whenever you stop at a particular function, you can just return a value instead of executing the body of the function potentially. Interesting that it doesn't work for errors. I guess that's the thing that you would need like resumable continuations for. I suppose I could do that here, but okay. The next thing to try, list all functions that will cause a debugger to break. Apparently in here you can press L to see the list of debug on entry functions, but right now there aren't any that are, there aren't any that are currently marked. But if I go down and use debug on entry on that same cycle indentation function and then press L, then we will see that that is in the list. So if you ever need to get sort of a read on which functions are going to break on entry, then you can use the L command in that buffer to do that. Let's go back and cancel debug on entry for that function. All right, what else? Oh, there's also eval and expression at the current stack frame. That could also be useful for figuring out the value of certain variables at a place in the code. So let's take a look at that org cycle.el. So maybe we can see, let's take a look at inline or line in position. I think that's a regular function, right? Okay. So we're going to make the debugger stop. And that's what, E? Yeah. All right, I'll press tab here. Oh, the backtrace is already open. There we go. So we're in the backtrace buffer again. I can press E. It will say eval and stack frame. I can call this line in position, and it will tell me 2119. And basically what that does is, like, wherever this was running, you can make calls to functions or ask for values of variables and get that context so that you can sort of see more information about what was happening at the time that that error occurred. That's probably something that is a bit more advanced. You'd probably have to understand what the code is doing before you want to start, evaling things there. But it could definitely help you if you have a really tricky issue you're trying to debug, using that E command to eval for the current stack frame. I wonder if it will let me do that for other frames. Like if I were to put my cursor on another frame. No, it's like currently executing, right? So this is a pretty simple debugger. If you're used to more standard debuggers like GDB or any debugger for another language, typically what you can do is actually move up and down the stack frames to set a stack frame as the current frame and then do things within the context of that frame. This basic debugger in Emacs doesn't seem to give you the ability to do that. But I think that the Edebug debugger will let you do it. So we might be able to see that in a little bit. Gunn was asking, will that terminate the frame prematurely? I wonder. I don't know for sure. It might. Let's see. What can we do? If we did that variable set, let's see, my variable, and set that to nil. Let's just put that back where it was. I'll just say 5. I don't care. And then press tab here. We're here now. If I press R, can I just press 5? Oh. Yeah. Okay. So it's telling me about the exit of the let binding. So it must have just let me return that. I don't know. It's hard to tell, actually. Maybe if I do this instead. Defun scheme is coming out of my fingers. Return something. Okay, so if I say return something, and it normally returns 5, but then I debug on entry or return something, then I call return something here. Maybe let's take that, cancel debug on variable change, take that out. So what I'm trying to do here is see if whenever I use debug on entry on return something, if I can just change the value that returns without ever having to execute it. That might be kind of a useful diagnostic tool, actually. So let's go here, press tab, and then press R, and then press 15. Okay, so cannot return a value at function entrance. Okay, so obviously there's limitations to this, and that's fine. It doesn't have to let me do all this funky stuff, but it was kind of interesting to experiment to see what was possible. So we've covered a lot of the stuff from the debugger. So let's start looking at Edebug. And this is one that I haven't looked at hardly at all. Like I was preparing for the stream today, and I didn't get a chance to look more deeply into Edebug. So we're going to figure it out on the fly here. So the major difference of Edebug compared to the plain debug is that you can actually step through the execution of a function. Plain debug does not really allow you to do that. You can just say, basically, give me the stack trace whenever a certain thing happens, and then I can look at it and then maybe continue execution. But you can't step through sort of line by line through a function call and understand what it's doing, and which is something that you would typically want to do with a quote-unquote real debugger like GDB. One of the most useful things you could do in a debugger is to actually just really go line by line through the code and see the value of all variables and see what functions are doing or which code paths are being followed. So Edebug is the only way you can do that for Emacs Lisp in Emacs. But the downside is that you actually have to explicitly instrument a function by evaluating it in a slightly different way. So you can use the universal prefix key, Control U, along with Control Meta X, which is eval defun, to eval the function definition with instrumentation turned on. Or you can just use, I think, the Meta X edebug eval top level form. So let's try that. Let me just go here and I'll add the advice back. And then I'll try to use Control U, Control Meta X on this function to see what happens. So Control U, Control Meta X. Okay, so maybe that worked. We'll see. Now, if I were to hit Tab here, let's see if Edebug kicks in. Oh, I think it did actually. There's actually a little marker here that's very difficult to see due to the color of my theme. But it does seem like we have the ability here to step through the code. I also see a couple bugs here. So the green one apparently is Edebug. Now these bugs are showing up here because of Doom mode line, but I think this normally you would see something in the mode line saying that you're in a debug mode. Debug on error. Let me turn that off actually. Okay. So now I should be able to step through this code. So let me check out the documentation for Edebug so we can see how to do that. This is in the Edebug execution modes section of the manual. So I'm going to pull that up. So let's see. In stops at the next stop point encountered after an expression. So if I were to put my cursor in this buffer, put it back in Emacs state, press N. Cool. So it jumps down to the next function call that would happen. So the reason why it does it like this is because we were outside of the let. There was no function calls here. It's just, values being set. But the first thing that happens in this expression is we're calling return something to pass it as a parameter to message. So that's the next place where things get stopped. Now, what we want to do is see what kind of information we can grab at this point. So there's a few other commands we can use here, but I would like to see how we might be able to grab some information. Can we get a backtrace? From what I read, you should be able to use the backtrace buffer here. Let's see, display a backtrace omitting Edebug's own frames. Okay, so views. Outside current buffer. Move point back to the current stop point in the source code buffer. That's cool. But it doesn't tell me what I'm looking for. Wrapping errors, eval, printing. Options. What about using Edebug? Can you step into return something? I bet you can. I want to see what the backtrace gives me first. Oh. B to set a breakpoint. G to execute until a breakpoint is reached. Q to exit. Type question mark to display a list of all Edebug commands. That's useful. So let's go back here and press question mark. Oh, it just gives you documentation on Edebug mode. Fine. That's really cheeky. So let's see. Backtrace, stack, trace fast mode, trace mode. What is... I don't know what that means. Begin trace mode. Okay, can you tell me? Edebug. No. Okay, so step mode. We might have to try that too. Display frequency count. That sounds interesting. Toggle save windows. Top level. Huh. So can I just run like a backtrace command or something? Let's go back to the scratch buffer. Backtrace mode. Oh, Edebug pop to backtrace. It's D. Okay, so D. Doesn't give me any information. Transient would be great for this. Yeah, it would be great for this. I imagine we'll see a lot more transient stuff showing up in Emacs now that it's built in. It's desperately needed. Okay. So we didn't get a backtrace here, which is really weird because there should be one. Let's just keep moving. We'll go back into execution modes. So if we press space, it stops the next stop point. So how about I press space, result 5, okay. And then if I press, what else? In. Okay, cool. So you can see it sort of exiting the parentheses and exiting the let expression, and then it gets out of the function. So let's try that again. I'm gonna press a tab, and I should already be in step mode here. Press space again. Oh, so if you press space, it steps for you. Okay, so it gets us right before this expression. Press space, it jumps to the return something. Press space. So return something itself is not instrumented. I don't know if it tries to instrument it. Yeah, it skips over it. It prints out result 5, which I think it did. I didn't do that. Okay, and then the result is 5. That's the result of calling message. And then I press that, press space again, and then it comes out. So that's pretty useful. You can step through a whole function. Let's actually try that with one of the org functions we were looking at, because we would get a lot more useful information out of that. So before I do that, I want to remove the instrumentation of this function, and the easy way to do that is just to reevaluate it without instrumentation, just using Control-X. And then if I go and press tab, I think it's breaking on the error here in the normal way. Oh, this is we already have, I think, debug on enter turned on. Cancel debug on entry. Yeah, return something is breaking, so let's get rid of that. So here I can just go back and press tab and everything's fine. All right, so let's go into org cycle. And I'm gonna go to this org cycle. Was it that one? Whoa, whoa. Oh, yeah, I turned off them. Okay. Org cycle item indentation. Org cycle item indentation. Okay, go to the definition. Yeah, go to definition. There you go. Okay. So on this one, let's try to run the other function, edebug eval top level form. So edebug eval top level form. Okay, so there I've instrumented this function. Now I should be able to step through that once I hit tab on this header. Okay, so now we are in edebug mode in the code for org list, where this org cycle item indentation is. And if I press space, I should be able to just jump right through. And the nice thing is, when I press space, it jumped over the execution of org at item and said that the result of executing that was nil. So it could be a very easy way to see what all the functions that are being called in this function are returning, so that you have an idea of what's happening. I'll just keep pressing space. Oh, it jumped over the entire thing? That's interesting. Why would it have done that? Oh, okay, gotcha. When org at item P. Okay. So, interesting that that happened. Why is it nil? It should have returned true, I think. Oh, okay. That's actually wrong. We don't want that. Let's see. Tab. Org cycle. Oh, we can just go to org cycle and do that one. So how about that? We will run edebug eval top level form, and then go back to the buffer, hit tab, and now we are in org cycle. And I can just jump through this whole function pressing space. Org load modules maybe returns nil. Jump into the unless, then we can jump into this or expression. Run hook with the args until success. We can see that returns nil. And then it will step to the next and. This thing returns true. Org cycle level returns nil. Yeah, so you just get a picture of pretty much everything. And if you use that edebug eval top level form on multiple functions, then you can actually step between them. But it doesn't work on any function that has not been enabled for debugging. So I'm in this function again, then we get back out, and then we just continue on with the execution of the org cycle function. So it's super useful to have that capability. And then I can, I think, press Q to just, continue execution and let it do what it wants to do. Let's see, what else can we do with Edebug? Let's check out the info buffer. Hello to Auntie Carol. Nice to see you. Auntie Carol says, came to YouTube to find something to watch whilst eating dinner. Found a dude hacking on Emacs. YouTube knows me. Well, yeah, that's good. YouTube is helping. Is this a regular thing? Yes, every Friday at this time. Who is not interested in S expressions? Well, I would like to know that. Actually, I'm sure plenty of people would tell me that they don't like S expressions, but whatever. All right, so stop at the next stop point encountered after an expression. Probably the same thing. Trace, pause, normally 1 second at each debug stop point. Interesting. Let's see what that does. I have no idea what that means. So, and there's also rapid trace, update the display at each stop point, but don't actually pause. Let's press tab. All right, we're here now. I'm gonna press T. Oh, it like automatically steps through for you, and you get to see all the values as it's going. Maybe just to get kind of a sense for what's happening. That's nice. You don't have to, sit there and just keep pressing spacebar the entire time yourself. So you can just watch Emacs execute the code for you. I don't know that I've ever seen that in Debugger before, but maybe I've never looked. So the question is, oh, okay, you leave the buffer and it pauses. That's good. Can you stop the tracing? Rapid continue. Move point to each breakpoint, but don't pause. What does that even mean? I guess maybe it just means don't stop anymore. I'm going to press T now. Okay, pressing... Oh, no, it kept going. So I'll press C. All right, so C just puts me back. C sort of cancels that. So I press C, then it just cancels the trace, and then it just continues execution. All right. I don't want to test it too much, but yes, the stream has been going for, an hour and 15 minutes, and it's been working pretty well. I haven't seen any problems so far. I had to make some adjustments to the streaming setup, and I think it actually did help out a lot. Okay. What else have we got to try out in the info buffer here? So we saw the continue makes sense. So you just wait until the next breakpoint. Go nonstop. Ignore breakpoints. You can still stop the program by typing S or any editing command. So it seems that there's a stop command where you can stop execution of a function at any given point. Maybe that could be used with T also. So let's try that. I'm going to go back and press tab here. I'll press T to start the auto tracing, and then I'll use capital S to stop it. Okay, so that does work. Cool. So if you want to stop whenever it's doing auto trace, just hit capital S and it will stop the debugger right at that location. Edebug is pretty cool. It seems to be useful, especially for package authors. I think if you're writing an Emacs package and you have a weird issue with it, it might be super, super useful. I'll have to start using this. Let's see, go nonstop. All right, cool. All right, debug set initial mode. Yes, Alejandro, I am in EXWM. I switched back this week and it's been going fine, more or less. Lucas says, sorry, just got on board at the stream. How easy is it to use the Emacs debugger for other debug server like GDB or PDB? Well, this is specifically for debugging Emacs Lisp. There's a different mode in Emacs called the GUD GDB, which basically allows you to run GDB inside of Emacs and have some, key bindings you can use and some other nice features for using GDB. But that only works for anything you can debug with GDB, so it won't work for other languages like maybe JavaScript or something. Though there is another way to do debugging in Emacs for other languages. A lot of these languages that have language server protocol implementations may also have a debug adapter protocol, which you can use with a package called DAP mode. So if I pull up a Qt browser here, DAP mode Emacs, you can install the DAP mode package to use these debug adapters for various different languages. It is a bit more complicated to set up than LSP mode or other language servers, but I've got a video on it, I think, that you can use to sort of get acquainted. Worth checking out. I don't really personally use it that much. I just, do printf debugging everywhere. I'm the worst debugging person ever. Gun says, is GDB capable of debugging eLisp? Probably not, but you could debug the C code of Emacs. Probably wouldn't be very helpful, though. Edebug set initial mode. Edebug set initial mode. I wonder if I can set that to change initial edebug mode from step to enter key. What if I press T? Okay, so you can basically set the initial mode so that whenever I go into edebug here, if I press tab, I think I turned off instrumentation. Did I do that? Let's do that again. Eval top level form. Go up here, press tab. Okay, so it doesn't seem to actually do what I expect. Set initial mode. Just no. Wow. Key must map to one of the mode changing commands. Well, it's not working. What does that function do? Edebug set initial mode. Must set a variable somewhere. I have to go fix that now. Old mode, edebug initial mode. Oops, let's check the value for that. Okay, let's do that. So set Q edebug initial mode to step. And now if I go back here and press tab again. Okay, so it starts working again. I don't know why it doesn't. Oh, now it works. What the hell's going on? That was really weird. Okay, so fine. Whatever. Whenever I change the debugging mode, apparently, oh, okay, it's already paused. That's the reason why it's not working. That's fine, whatever. So let's see, what else do we have in the info file that we could try out? Edebug sit for seconds. This option specifies how many seconds to wait between execution steps in trace mode or continue mode. So if you think that in trace mode it's moving too fast, you could probably use this edebug sit for seconds variable. It seems to be set to 1 by default. You could set it to 2 or 3, maybe if you want to have more time to sort of inspect what values are being sent. Sorry, 1 second. I have to help with something really quickly. Okay. Anyway, so you could definitely set that to a longer duration if you wanted to. Probably not something we'll try right now, but that's kind of cool to have. So that was the execution modes. It's good that we went through that because I didn't really know what they meant by execution modes, but really it's about whether you're stepping through the lines of code individually or if you're letting it do the auto tracing functionality for you. Let's see. So yeah, it's basically explaining it here. Edebug is a source level debugger with which you can step through evaluation, stopping before and after each expression, set conditional breakpoints, which can be very useful. So maybe, can we set a conditional breakpoint somewhere? Where is internal old mode? Yeah, this is edebug code. We don't want to look at that. Hey, don't do that. I think I have debug on error set. Let's get out of that. Gun says, is there a just-in-time instrumentation function that instruments a function when it's encountered? No, but there is something you can do to cover more of the code of a given package. So where is that at? I think I have it here. There's a variable called edebug all defs. If we look at the documentation for that, it says, if non-nil, evaluating defining forms instruments for edebug. That's a very terse statement, but what it's saying is if you set this to true, any function that you eval will now be instrumented. So what we could do is set q edebug all defs to true, go back into orgcycle.el. I don't know what this is going to do, but let's just eval buffer. And now you can see edebug says some things here. I think what it's telling us in the messages buffer is that it's instrumented all the functions inside of this file. So it doesn't give you all the functions in Emacs, but at least you can, from this point forward, any other functions that I eval are going to be instrumented. So maybe if you require a package or if you force reeval certain aspects of the code, certain files, then all of them will be instrumented, and then you can step through the entire package, which could be pretty useful for more complicated packages. So let's try that. We'll go up here and press tab, and let's see where we end up. So it's doing auto trace mode. Let's just see how far it goes. So Ramses says, what do you mean by instrumented? That's a great question. So why did it stop there? Keep going, T. So instrumentation is when you inject stuff into a function that helps with things like debugging or performance counting, etc. So you have your initial function definition that you wrote yourself or that someone else wrote. And then instrumentation is basically saying that before every line of the code, it's injecting some kind of code to give information back to the debugger about what's happening. So the actual real definition of the function is a lot more complicated, I think, than what you would originally imagine. Let's see if we can look at what org cycle looks like. Whoops, let's look at the function org cycle. Let's see if we get a disassembly on that. Yeah, this doesn't tell me. It's probably just pulling the original source. It would be nice if we could see like a disassembly, see what it's doing to the function, but we can definitely see edebug has some stuff here, like some kind of frequency count. It's adding a lot of extra stuff to the function execution. Coverage. There's like some edebug metadata, like some kind of marker maybe. So there's a lot of stuff here that it just adds stuff to the function so that it can be used in the context of edebug. Alejandro asks, if we enable that in our init.el file, could all of our functions be enabled to debug? Yes. If you put that setting at the first of your init.el file, then I think all of the stuff in your init.el will then be, well, all of the stuff, if you put this edebug all defs to true in your init.el at the very top, everything that loads in Emacs will be instrumented in theory. And then you could step through all of the code or all of the Emacs Lisp code that's been loaded into your Emacs session. That might be super slow to set up, and it might be super slow to use, but it is possible to do that if you really, really needed to figure something out. So I wouldn't recommend doing that at the beginning of your init.el, but you could turn it on before you load a particular subsection of your config and then turn it back off after that. And then maybe it could be good for stepping through everything. Gun says, what about natively compiled functions? Good question. I don't know what the answer is for that one. I don't know if it falls back to the original. I'm looking at credit card transactions. I have to help my wife to approve something. What was I saying? Yes, natively compiled functions. I don't know if it uses the original definition. So it would be good to find out. I'm guessing that all this org cycle stuff that I'm messing with is natively compiled. In fact, how about we just go look? Oh, it's auto-loaded and interactive. Now, because I messed with it. Oh, well, it's not natively compiled now because I've reevaluated it. So I think that's what's happening. Error1 says, you need a bigger brain stack. Well, if I didn't get distracted, then we wouldn't have a problem. So when you instrument a function for Edebug, you are reevaluating it by definition. So because of that, it's not natively compiled anymore because you've reevaluated it in the session. So I think that's what the saving grace is. All right. The stream can wait. Thanks, Osloy. So let's see. What else can we do? Let's see the info buffer. So we didn't find conditional breakpoints, but maybe we can find that in the stuff here. Trace slow or fast, display expression results and evaluate expressions as if outside of Edebug. I don't know what that means. Automatically reevaluate a list of expressions and display the results each time Edebug updates the display. That's like a watch expression, maybe. Yeah, that would be cool. Output trace information on function calls and returns. We did see that. Stop when an error occurs. I guess it probably turns on debug on error by default. Display a backtrace, which didn't seem to work. Maybe if I go in there now, it will do the right thing. Let's try that again. I think it was D was the key for that. Why is it not debugging anymore? Let me eval that. Oh, debug on error. Is that necessary? Interesting that it stopped responding. Did we determine what trace means? Yes. Trace is whenever it automatically steps through your code, sort of expression by expression, and just prints out the result of each sub-expression. It's just like an automatic stepping logic, which actually is pretty useful, I think. If you want to just sort of get the gist of, excuse me, of what a particular function is doing. Okay. Let's take a look then at why this is not working. Because now we don't get any I'm trying to think of why this would be happening. There's no error there anymore. Oh, did I need to set like a debug on entry or something? Edebug. Edebug on entry. Cause Edebug to stop when function is called. Org cycle. Okay. I may not have even done that before. I don't even know how it was working. So it was not doing what I expected. Okay, so Edebug got run again. What about set initial mode? That's really strange. You know, I think I was sitting in Edebug and it was waiting for me to do something. Jeez, okay. All right, so we're back. We're in the buffer now. Let's just, you know, cruise through a little bit. Let's get into that let expression. Right about here. I'll press D. Okay, so it does give us a backtrace. That's cool. And this is an edebug backtrace buffer. I can use the plus sign, I think, on this line if I get out of Vim state. And then it will expand like it did before. I can use minus to put it back. V to see the locals, but it doesn't give me any locals, which I find kind of weird. Because there's a let above this, which should have defined limit level. So that's kind of unexpected, but okay, whatever. What else do we want to take a look at? If org odd levels only, what is the value of that variable? Okay, it's nil. Inline task min level. Let's see. Does it have a question mark for help? I think it does. Yeah, it just pulls up Edebug mode, which is kind of annoying. But maybe you're asking about the backtrace buffer. Question mark? Yeah, question mark is undefined in the backtrace buffer, unfortunately. Okay, let's see. So let's take a look at the menu here. Jumping, commands to jump to a specific place. Proceed to the stop point near where the point is. Oh, that's kind of cool. So the stop point is here, but if we go down to right about here, I can press H, and it will, well, in theory, it would run Edebug. It should have run right up until this point, but it didn't, which is kind of interesting. What if I press space? Okay, so it steps. And if I put the cursor here and press H, okay, not doing what I expected. Run the program for one expression to go forward. Okay, so that worked. F does seem to, oh, it set a breakpoint. Edebug. Show debug windows and where we stopped in the program. Let's use this edebug where. Edebug is not active, but maybe it jumped out already. Do you first have to define a stop point? It's possible. Let's take a look at that actually. Continue. What if I put it right here and press H? Okay, it still doesn't do what I expect it to do, but it's creating breakpoints, it seems. Can I click there? All right, let's try it again. Run the program until the end of the containing S expression. Moss says, I've compiled Emacs 29 with native compilation enabled. Strangely enough, it recompiles all the packages on every startup. I've heard of this issue before. I wonder if maybe your path where you are storing the native compilation outputs is like getting cleared out somehow, maybe. Alejandro asks, why am I not using keycast mode or keycast tab bar mode? Let's see if that works. Hey, okay. It's kind of nice that it allows you to do that. Well, we put that on now. Thanks for reminding me, Alejandro. I should probably just turn that on by default when I start streaming every time. Okay. Step into the function or macro call by the form after point. So where are we? Maybe if I go to the buffer here. Stop point near where the point is. Maybe you're right, Gun. Is scanning the vicinity for any breakpoint. You're probably right. All right. What I was going to look at. Step into the function or macro called by the form after point. So if I just press I here to step in, you must be before a list form. Okay, so that does work. You can just use I to step in. Interesting. Okay. Go back to info. H command proceeds to the, okay, so Gun's right. The H command proceeds to the stop point at or after the current location of point using a temporary breakpoint. Oh, okay, so it basically tries to insert a breakpoint at the location and then tries to execute to it. So let's try that again. I'll go and hit tab here. Oh, I'm probably in the middle of execution. Wow, what'd I just do? Press tab. Come on, where are you? Oh, what happened? We're tracing through subber. Yo, that's crazy. Can you stop trying to execute? What is happening? It's literally trying to catch every execution of the when macro. No. I don't want that. Stop. Why did this happen? Okay, I need to go back and find... I think there's something called Go. Go nonstop. Ignore breakpoints. G. Thank you. That was weird. Yeah, Judy Dev says in the Twitch chat, check your native comp ELN load path. Maybe it's set to a caching or temporary directory. That's basically what I'm saying. Okay. What else? We haven't looked at breakpoints. Let's try breakpoints. Maybe we should try something else because now I've kind of gone too far. So what I'll do is I'll go turn that Edebug all defs back to nil, and then I will reevaluate this buffer because I don't want it to be instrumented anymore. I think that if I do that, I should be able to go back into here and press tab, and then it doesn't run the debugger. I hope it doesn't. Oh, to start again? No, okay. What is happening? Compiled function. What was that? I see it here. And it's in the win again. Edebug. Is there a way to just remove everything? Oh, toggle edebugging of all forms, of all definitions. Okay, interesting. Interesting that Lispy has some integration here. See you, Gun. Thanks for coming. Continue mode. Set breakpoint. Okay, so there's some key bindings, some global key bindings you can use for changing the modes. Oh, I think I also had set edebug, cancel, debug on entry on org cycle. Let's just get that out. All right, let's try that again then and see what happens. So hopefully it's still doing it. I have no idea why all of a sudden we're debugging win every time. Let me reeval win. How about that? Hopefully that will get me out. That is very strange. Okay. I don't want to eval buffer. Let's go back, press tab. Yeah, it's doing it again. Org load modules maybe. I don't want you to be instrumented. Can you just not do that? All defs is null. Use G to exit. Hit tab again. Org cycle item indentation. Did I not? Oh, this is a different file. Okay, eval buffer. Cool. Quit. I'm really upsetting my mouse apparently. Okay, I think we're finally back to normal. Let's go into the scratch buffer. What I wanted to do was test a different kind of debugging that I saw in the info buffer. Okay, I want to set breakpoints and kind of check some things out. So if I go into scratch buffer, I will eval this form to be instrumented. And then I'll go back and add that advice again so that it will be triggered whenever I hit tab on one of these. Okay, I see something happening. There we go. Okay, so it drops in here. So in return something, I wonder if I could set a breakpoint there. So how would I do that? I go to the info buffer. Hello. How did I end up in a different workspace? That's funny. Scratch. Okay. Info. There we go. So breakpoints. Use B to set a breakpoint at the stop point or after point, at or after point. Okay, so if I go into Scratch and then press B, not inside instrumented form, it would probably need to be a function call. So let's just quit out. Go into Scratch. I think that's why I'm having trouble here. My other workspaces are all on Scratch, so switching buffers is kind of weird. All right, let's check out this return something. I'm going to call like, 4 + 1 and see what that does. I can eval this function and then go back into the org file, press tab, and that will trigger the debugger. I can go here and press B. Not inside instrumented form, not inside instrumented form. Interesting. What if I press B on this? Okay, breakpoint set in do bad thing. Can I use another key to get out of it? Unset breakpoint. So then I can go here and press U to clear it. Okay, so that makes sense. What about right here? Okay, so I can set a breakpoint at the end of the function and then press, I think C or maybe G. Does G work? Yeah, I think it stopped there, didn't it? Okay. I like how mouse movement is telling me I'm calling a compiled function. Going back to the info buffer. Move point to the next breakpoint in the current definition. Set a conditional breakpoint which stops the program only if evaluating condition produces a non-nil value. Let's try that. So that was capital X and then type in the condition. How about I go into the file here? Can I press U? No. I have to be in Edebug mode for this to work. All right, so if I go back to, let's do this. Pull this buffer, jump down to here, press tab. Huh. Try that again. Doesn't seem to be getting caught anymore, which is kind of interesting. I don't know if I broke something. Oh. Okay, Edebug mode is not on in this buffer currently. So I think I reevaluated this function without the instrumentation on. Maybe I can use Edebug, cancel or breakpoint, unset breakpoint. Is it? Because I don't see it unset. What if I set a breakpoint? Conditional breakpoint right here. Edebug set conditional breakpoint. Actually, no. Maybe right here is where I want it. So set it right here. And I'll say, oh, I don't know if I can get the return value. Can I find what the return value is? Test a condition each time the program gets there. Any errors at the error occurs as blah, 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 whatever. Can I get the value of the expression? That's kind of the only way that it would be useful, I think. Yeah, they're not really explaining that, are they? Embedding breakpoints in your source code. Yeah, okay. You can just call Edebug. That's fine. Global break condition. Okay, so you can set up global break condition. That's fine. All right, anything else cool worth looking at? I mean, we've got, you know, a few minutes left before stream is over, so we'll just see what else that might be useful. Data that Edebug saves and restores. Might be interesting to see what this is. Tries to be transparent to the program that you're debugging, but does not succeed completely. Temporary restoring the outside context. So I guess it tries to give a clean context for evaluating certain expressions or the code that's being run. Okay. Wrapping errors. So it seems there's a lot of the same kind of functions that you saw with the previous debugging package. They're sort of replicated here in Edebug, like debug on error, debug on quit, etc. So if you're using Edebug, those might be helpful. Eval list, expressions whose values are displayed each time you enter Edebug. Switch to evaluation list buffer. I can use edebug visit eval list. Probably because it's not running at the moment. Evaluate the expression before point in the outside context and insert the value in the buffer. Okay, so it basically seems like you can just set watch expressions if you ever use a debugger that lets you do that. It gives you the ability to, every time the debugger steps to another expression, it updates this list of expressions that are being printed out so that you can sort of see how values are changing over time. It'd be pretty useful for debugging package code, I think. I don't know if you would want to use a lot of this stuff for debugging your actual configuration file, though. All right, printing in Edebug. Print level, print length. Okay, I guess it's just for printing out things in the backtrace buffer, potentially. Produce trace output in a buffer. Can record an execution trace, storing it in a buffer called Edebug trace. So that's more like a trace that I would expect. Just tells you which functions get called through invoking some bit of the code. Miscellaneous commands. Help message, abort one level back to the previous command level. Q for quit. Okay, that's where displaying the backtrace was, in this MISC listing, which is the wrong place for it. This should be somewhere else that's more obvious. Display a backtrace excluding Edebug's own functions for clarity. So Edebug popped a backtrace. Well, hopefully that was useful as a way to sort of learn more about how to debug code inside of Emacs Lisp. I'm guessing that most people aren't so interested in Edebug as they are in just the regular debugging functionality in Emacs, as I could tell from the number of people who dropped off after I started talking about Edebug. But I think it's good to know about both these things, especially as the complexity of the Emacs Lisp code that you write starts to increase, because you need the ability to, you know, debug things and understand what your code is doing, especially your configuration code. I haven't really been using any of this stuff in the past. Only toggle debug on error and maybe toggle debug on quit. But I've learned a few things myself today that I think that I'll be using in a lot of places, because you know, to have the full introspective capabilities of Emacs to find documentation for all functions and variables, but also be able to interactively step into all of the Emacs Lisp code. It basically gives you the ability to just like be one with the system. You can just see everything and know how everything is working at any given moment. So pretty cool, I think. At some point, I'll make more focused videos on how to use these things. I don't know that I would cover anything more than what we just covered today, but I think that debugging in Emacs Lisp is probably one of the lesser known things or lesser experienced things. So I would like to be able to encourage people to try that. So that's about all I had for today. I hope that you all have a great weekend. And also, like I mentioned before, go to that post on Mastodon and reply. Let me know what kind of content that you want to see in the next year. Excuse me. Because this year, I've not made, let's see, how many videos did I make? I may have made 2 or 3 actual System Crafters videos this year, in addition to all of the streams. but like real tutorial focused content, haven't really done very much. But next year, I'm going to get really back into it. I'll try to do videos at least every 2 weeks, maybe once a month if it gets too difficult. But I really want to get back into it because I feel like I'm missing that, you know, that flow of producing actual tutorials that are useful to people. I think it'll be really good for the channel to do that. Thanks so much to Ross.
That was a Tom of stuff. THX Dave.
Okay. The voice had to speak on your behalf there, Rostislav, but thank you very much for the €5 in Super Chat. So yeah, let me know what you want to see next year. I think we'll do another stream next week. I'm not going to take the next week off because why would I do that? So if you've got ideas for what you would like to see in the next week's stream, definitely leave a comment after the video, or even tell me on Mastodon after you go there and leave your other comment about what videos you would like to see next year. But anyway, thank you all so much for being here today. Really appreciate your time and attention. And we'll see you back here next week. Until then, happy hacking. Thanks a lot.